Alrighty, so welcome back. Today in this video, we're going to be doing some statics review for the Civil FE exam. And we're going to be focusing specifically on frames and trusses. So being civil engineers, this is what they always show and share that we do. Always like doing something with bridges, designing bridges, some sort of frame or truss. And so now we actually get to do that piece of thing. So let's go ahead and look at a few practice problems and let's get into it. So number one. All right. Number one says the Pratt Bridge truss is loaded as shown. Use the method of sections to determine the axial forces in member CE. All right. So what information are we given? We're given an image with external loading. All right. From this, I see a bridge that was 17 times 4. It's 200. No. 68 feet coming across, 8 feet high. It has a few loads that's pulling down on it, which is strange to me, but 10 kip, 30 kip, and 20 kip. And the frame looks somewhat, well, not really symmetrical because there's different forces. So these are the things that I'm just kind of noticing from the beginning. So they give us external loading, dimensions, and when I say external loading, that just means forces that are acting downward that are shown. Okay, so it says find the force in CE or member CE. Let's change the color. Black is kind of boring. All right, so the force in CE and anything else. We need to do it using the method of sections. What is the method of sections? Method of sections. Can we search this in our handbook? Method of sections. Okay, two things come up. All right, first thing for a plain truss. Look at here. All right, hopefully you're following along with me. Maybe I can just move myself. All right. So this one says, for a plain truss, the method consists of drawing a free body diagram of a portion of the truss in such a way that the unknown truss member force is exposed as an external force. Okay. It's about all the information I think they're gonna give us. Yeah. Perfect. So we gotta draw a free body diagram of a portion of a truss to get the unknown truss member. So let's do just that. Let's pretend that we do not need to see anything but a portion of this truss. So I'm going to break it up and I'm going to draw again. I'm gonna redraw it. All right. Bear with me, because you see I'm nervous drawing this thing. Just want to make sure I'm drawing it to the best of my ability. All right. So I'm going to break it here, here, here. Okay. So here's what I did. Just basically cut it. And here's my truss. So we still have, when we cut this thing, you still have a downward force, the 10 kips. I don't know. So there has to be some sort of pin or roller that's acting on this. So if there's a pin here, I don't know what that force is. So I'm just going to call that AY, AX. So that's an unknown. And we are trying to find this CE. What's the force in CE? So I'll just mimic that just to keep in mind, so you know what we're actually looking for. So how do we get this? Well, first, there's so many unknowns to where I feel like for point B, this is point A. I feel like if I took a moment, so this is you got to put some thought into this before you start going at it. I feel like if I found AX, I could take a moment at, if I knew what AX and AY were, then I could take a moment at B and I would be able to determine a force, which is the force in CE, and I would be able to multiply it by a distance of 8 feet to get my, that would be the only unknown. Like if I took a moment at B, I would know what AY is, and I would know what the distance is, which is 17 feet. These forces here don't matter. That's attached to B because there's no distance between them. So the forces in those would just, the forces would be the forces, but the distances would be 0, which X's them out as variables. And then my CE has a perpendicular distance of 8 feet. So it would be CE times 8. All right. So probably thinking, whoa. How are you knowing all this? Okay. So let's break it down. Start with step 1. Just you got to use the information that they give you. So I do not know what AY is. So how do I get AY to start? Well, if I do I take a moment at A, I can find HY. And if I can find HY, then I can do the sum of the forces in the Y and determine what AY is. So let's try that. So first, I'll start by saying sum of the moment about A is what? Sum of the moment at A is, first of all, your first force, which is 10. Was that 10 a positive or a negative? Well, I'm saying that anything that is counterclockwise is positive. So in this case, if I pull this down and around, pull it down and around, right? So that's going to be a negative, right? It's going clockwise. So negative 10 kips times, what's the distance? It's the perpendicular distance to A, 17 feet. Okay, what about the next force? Well, it's 30 kips. So same thing, minus 30 times, what's my distance? Well, if I'm taking a moment at A, I have a distance of not just 17 feet, but it'd be 17 plus 17, which would be 34, right? All right. What else? We're gonna run out of room here, but we have I'm gonna continue this. It's gonna be minus 20 kip. And I won't write out the kip because that's a little bit confusing. Minus 20, right? 20 kips times, what's my distance from my force to point A? Well, 17 times 3, which is 51. Okay. And then are we done? No. We're trying to find HY. So there's a reaction at H, at the roller, that I'm assuming is going to point upward, plus HY. And not only I'm assuming upward, but that also, if we do that, if we push it up, right, it's going it's going counterclockwise, which is positive. So what's my distance from there? It's going to be 17 times 4. And that's 68. Okay, so we have one variable now. So this is why I said there is reasons why you want to be strategic about solving for certain things, because it will allow you to separate variables. That way you can isolate them to be able to get exactly what you need. So as you do practice with this, you'll get better with it, but you need to identify which variable can you isolate that is an unknown that'll help you solve for the next thing, right? And so for HY, I get HY is equal to 32.5 kips. Okay, in the upward direction. All right, so now we can do sum of the forces in the Y direction is equal to, okay, we know that we have a reaction that we don't know, AY. We know that we have some forces, minus 10 kips is the first force, minus 30 kips is the second force, minus 20 kips, third force, and then we have that reaction force plus 32.5. All right, what is AY? AY, once I plug it in, is 27.5 kips. Okay. Upwards. All right, so now we know what our AY is here. So you see me erasing that variable, and now we know that it is 27.5 kips. Okay. So now that we know that, we can go in and see if we can take a moment at B, right? So if I take a moment at B, let's look at it. Sum of the moment at B is equal to, if I'm going upwards around B, it's going to be a negative moment because it's clockwise, right? So it'll be 27, negative 27.5 kips times my perpendicular distance, which is going to be 17 to the point, to point B. So, and then what other forces do I have? Well, I have this 10 kips coming down, right? And we'll just say plus 10 kips. But what's my distance? What's my perpendicular distance? My perpendicular distance is 0. So that's going to cancel out anyways. Okay. And you could say the same thing for BD. Just say plus BD, the force of BD. And we don't know that, but we also know that that distance is 0, so it cancels. And we also know that BE times 0. Okay. And our last, so that cancels, this cancels. So the other variable that we need is our CE. And I'm going to say if it's swinging to the right, I'm going to say it's going around B, counterclockwise, which is positive. So I'm going to say plus CE times what's my perpendicular distance from CE. It's going to be 8. Right here. That's where I'm getting that number from. All right. So now for CE, what that breaks down to, CE is equal to 58.43 kips. All right. So we get C. So definitely manipulating your answers or your variables, very, very important that you manipulate them and break them up into, okay, what can I do to get one alone? What can I do to get another one alone? And go from there until you're able to get exactly what you need. All right, so let's look at number 2. All right. So this one says the Pratt Bridge truss is loaded as shown. Use the method of joints to determine axial forces in members A, B. Okay. So first things first is that we are given image, right, with external loads and dimensions, right? Okay. I'm going to go ahead and give you the values of AY and HY. So AY is going to be 27.5. 27.5 newtons. And this reaction here, AX, is going to equal to 0. All right. HY coming up is going to be 32.5. This is the same. Just want to save some time. I don't want to walk you through that whole process again, right? Okay, so we're trying to find the force in AB. And we want to do it through method of joints. MOJ, method of joints. Sounds cool. Method of James. But method of joints. Okay. So what are the formulas that we need? Well, what is method of joints first and foremost? We're already in the same section. Method of joints is here. All right. So basically the method of this method consists of solving for forces in the members by writing the two equilibrium equations for each joint of the truss. Okay. So the horizontal forces and member components is equal to 0. And the sum of the vertical forces components is equal to 0. All right. All right. So basically, you need some prior knowledge on this too, because what does it look like? All right. So we want to find the force AB. So that means we're going to use method of joints to do that. And so when you're doing method of joints, you have your joint A, and then you want to draw all the forces that are happening on it. So on this joint, we got AB. We have AC coming to the right. We have an external force from the pin. It's a reaction, but it is external, and it's 27.5 newtons. That's the force. And then we have another external force from the pen that equals 0 newtons. So that's the horizontal and vertical. Okay. So now, just looking at this, what are we trying to solve for? We're trying to use method of joints to solve for AB. So I know that I need this force. Okay. So is there a way we can do the least amount of work and get AB? Let's do the sum of the forces in the y direction. Okay, why would I do in the y? Well, if I do in the x, if I do the sum of the forces in the x direction, let's just say sum of the forces in the x, I got to deal with this 0 newtons here, right? I got 0 newtons. Then I got to deal with AC, which I have no clue what that variable is. Then I have to deal with plus AB, which I don't know what it is. And then I need to figure out also what, my values are to get the sine or cosine of it. Because you're basically given AB, but then you need to solve for the, it's not just, you need to solve for the x component for that. So it would be like 17 would be the top. Oh my goodness. So I would need to say, okay, what's the x component of this? So my x component would be 17 over be the square root. Oh my gosh. So it would be 17 over, since they don't give us that value, be 17 over the square root of 17 squared plus 8 squared. So anytime you're trying to solve for a hypotenuse value, then you have to do x squared plus y squared all over the square root, and that gives you the actual distance, right, of it. But we just want the x value of that. So a lot of unknowns ultimately. You got AB is an unknown and you have AC. So don't want to deal with that. So what's another way? Another alternative could be the sum of the forces in the y direction. Okay. And so what does that look like? Well, we know that we have 27.5 newtons coming up. We also have, we don't have to deal with AX, right? We don't have to deal with AC because those are forces in the X direction. So the only other force we have to deal with is, it's going to be a plus because the Y value is happening upwards, right? If this thing was leaning this way, then it would be negative, right? Because our y value would be coming down, but our y value is going up. As x increases, y is also increasing. So. Okay, so the last thing that we need is AB, and then what is our value that we need to multiply it by? We need to multiply it by the y value, which is going to be 8, right? All over the square root of 17 squared plus 8 squared. So anytime you want to get a force in the x, force in the y, you're going to have to do some sort of force times its cosine, or force times its sine. All right. And so let's go through why we went this way. Well, what is cosine, right? Cosine is adjacent over hypotenuse, right? Adjacent over hypotenuse. Well, sine is opposite over hypotenuse. So in this case, anytime you're doing y, you're trying to find the opposite over the hypotenuse, or cosine. Or sine. So sine is opposite over hypotenuse. So what's our opposite? Well, our opposite, when we look across here at our y value, it's 8. What's our hypotenuse? Well, we don't know our hypotenuse. This is the hypotenuse. We don't know that distance. So we say, how do we get the distance? It's going to be 8 squared plus, so y squared plus x squared. What's our x? 17 squared. All over the square root. And that gives us this value, the hypotenuse. That makes sense. So basically, we just did a force times sine, force times sine of theta, which ultimately is how you had to get the y. This is how you get the y component. So that may have been a little confusing, but you want to know why you're doing certain things, and so this is why. So AB is going to be equal to 64.6 kips, or D. Or no. Huh. Now you're getting me. All right. So it's going to be 64.6 kips, but I know that this is a negative, right? Why is it negative? Because that's what it came out to be once you swap the 27.5 to the other side and went through your progression. So I know that I'm getting a negative kip. So what does that mean, right? Anytime you have a beam or truss platform and its force is pulling it, this would be considered anytime you have this beam or this truss member and it's being pulled and stretched outwards, it is in tension. Right. Now, the way I assumed was that it was stretching outwards. That's why I said I assumed my X value and my Y value, I assumed it was going upwards, right? And I assumed it was going outwards to the right and upwards. But for this case, it came back negative. So that means the way that I drew it was in fact wrong. And it's coming back the opposite way. So whenever you get a negative number for something, it just means what you assumed was incorrect. And that is not actually in tension. AB is going to be in compression. So it should be 64.6 kips in compression. So I get D. Alrighty. Let's look at number 3. Alright, so it says the Pratt bridge truss is loaded as shown. Use the method of joints and method of sections to determine the members in AC. All right. So I'm not going to make you redo all of this. This is all the same stuff. We're just going to use what we got for AB. To be able to solve for AC, right? So we did the method of sections, or we use method of joints. We can do a cut, however, but we already have a lot of the values that we need, so we're just gonna use them. So I know that AB is acting this way, and it is 64.6. I know that we have an upwards force of 27.5. That's external. I know that this is equal to 0. And we're trying to find this. And I'm assuming that it's this way. Okay. So by using method of joints again, we're going to say that this is our joint A. And we got this member. And we are just pulling that one. We have this member here. And we know that it's actually coming down that way. All right, anything else? Oh, I know that we got a force. We have a force coming up, 27.5, and this is 0. All right, so we kind of have to use some of the forces in the X, because some of the forces in the Y is not going to help us at all, because we're trying to find AC. All right. So switching pins here. All right. Sum of the forces in the X is equal to AC and then we're saying plus AC because I'm assuming it's going to the right. All right, what about, what's the other forces that, to make this a little bit more clear, I'll put this is C and this is point B. Okay. I know AC is a positive. What about the X component of AB? So so I have plus 0. This one is 0 newtons. All right, AB. So I would expect that AB in the X direction, it's going to the left, and it's coming down in the Y direction. It's going down and to the left. So to the left, it's going to be your minus AB or not minus, we've drawn it the correct way. So there's going to be plus AB. And then what else? AB, and then we need the value of X. So how do we get that? Well, we take the cosine, which is going to be adjacent, the adjacent distance, 17, over the square root, 17 squared plus squared. Okay. All right. So our AB from last problem was negative 64.6. So you got AC plus 0 minus 64.6. 17 over 17 squared plus 8 squared. All right, all that's in parentheses. And then the last thing is just solving for, this is all equal to sum of the forces in the X, which is equal to 0. So AC is going to equal 58.5. And it just means it's a positive value, so it means that it is in tension. And only because we drew it the correct way. So if this number would have came out negative again, then we would have known it was in compression, but 8.5 in tension. So signage is very important for this. You got to make sure you're drawing out things correctly. And if you just always want to draw, I normally always draw my members out in tension, but in this case, since I had already knew since I had already solved AB and knew it was in compression, I just drew it in the correct way, but I still needed to leave my signage as negative, right? Or once I plugged in my value, I needed to plug in a negative because everything typically is drawn in as being in tension. That's just how I typically draw things. So hopefully this helped. A little confusing, but for the most part, it's just a sum of the forces type of game, and you got to know what's your unknowns and what you're solving for. So in the next video, we'll be going over centroids of areas. So